Hi there, and welcome to the video. Today we're going to have a look through some common constructions which you may be asked to do during a test or an exam. We're going to start with constructing a triangle when given an image of the triangle. So here's an image, but it is not drawn accurately, and you're being asked to draw the triangle accurately. First thing we know is the base of the triangle here is 8.5 centimeters. So I'm going to use my ruler to accurately draw 8.5 centimeters. Now I'm going to use this angle of 42 degrees and my protractor to measure an accurate angle of 42 degrees. Notice that I'm using the inside scale for this angle and that the crosshairs of my protractor are on the start of the line where the angle will go. So I just put a little mark there, use my straight edge or my ruler to draw in the line at 42 degrees. At the minute, we do not know where the point K lies, where angle K is, but we're going to use this angle of 57 degrees in order to find K. So I'm going to go to angle L. I'm going to use my protractor again. This time, because we're in the other direction, I'm going to use the outside of the scale and measure 57 degrees. And again, with my straight edge or my ruler, I'm going to draw that in. Where the two blue lines meet, this will be the accurate location of point K. So here we have angle K. I'm just going to draw that in and label it as angle K. So what we have here is an accurate drawing, a scale drawing, accurately drawn, and it's a representation of this diagram here. Let's have a go at another one. So I'm given some information about this triangle, and I'm asked to draw it accurately. First thing I'm going to do is I'm going to draw the base of 7.3 centimeters. So I use my ruler to measure 7.3 centimeters. Next bit of information I have is this angle here, 64 degrees. So I'm going to use my protractor. I'm going to use the inside scale to measure 64 degrees. Unlike my last question, I know that this length is 9.2 centimeters. So when I come to draw in my line from X through this point here, which will give me the correct angle of 64, I make sure I draw it in as 9.2. So I've used the 3 bits of information in the question to find the accurate point of Y. So this, at the end of this line, is where angle Y would be. So then if I join up Y and Z, this now is an accurate scaled drawing of this diagram. This is exactly 64 degrees, exactly 9.2 centimeters, and exactly 7.3 centimeters. We also need to be aware of what we call the ambiguous case. So there is sometimes 2 possible ways to answer the question. So for example, if we have a go at this question here, and we draw the triangle as such, starting with the base, we use the 48 degrees to measure accurately, and we're going to draw in 8.2 centimeter line. So I've just drawn in the line from L to M. And from there, I need to come back down to meet the base 6.5 centimeters. So I'm going to draw a line down 6.5 centimeters. But you'll see from my diagram that that is not the only option we have. Because from M to N at 6.5, so this is 6.5 and meets the base, there is also another option of coming down here at 6.5. So that is one possible solution, but we also have a second solution. Notice at this stage that what we've created here is an isosceles triangle. That gives us the 2 possible options. If I just make them a little bit easier to see, that would be our first option, and this would be our second option. They still both contain an angle of 48. They both contain sides of 8.2 and 6.5, but they are two different answers. So they both reflect the information in this question and they're drawn accurately. But what we didn't have was we did not have enough information to know whether this should be the correct answer or this should be the correct answer, which is why we call it the ambiguous case. And in this case, you would usually give both solutions. Okay, so the information can be interpreted in more than one way, so just be aware of the ambiguous case. Okay, next one to have a look at. Using a ruler and a compass to construct an equilateral triangle with sides of 8 centimeters. So I'm going to start with the base. I'm going to use my ruler and I'm going to draw the base at 8 centimeters. This is when my compass becomes handy. I'm going to place the point of my compass here and I'm going to open it so it is exactly 8 centimeters wide. Keeping the point of my compass here, I'm going to draw an arc somewhere up here. So with the point of my compass here, I've drawn an arc here and I've opened the compass 8 centimeters. I'm going to take the compass and I'm now going to place the point over here. Keeping the compass open at 8 centimeters, I'm also going to draw an arc up here. Okay, so this point here down to here is exactly 8 centimeters. This point here down to here is exactly 8 centimeters, producing a very accurate equilateral triangle. Very important that when you're constructing this, you open the compass to 8 centimeters and you do not change how wide the compass is open. It remains as 8 centimeters up here, and then it remains as 8 centimeters when we draw this final arc as well. Okay, so we can extend that method to just draw triangles which aren't equilateral. So I'm going to use a very similar method. I'm going to draw my base of 6.3 centimeters, and then I'm going to open my compass 5.7 centimeters and place the point of the compass here. So the point of the compass gets placed here, and I open my compass 5.7 centimeters and draw a nice arc. Then I'm going to move my compass over and place the point here, and I'm going to open my compass 4.2 centimeters. Then I'm going to draw another arc which is going to cross the blue arc I already have drawn. Something like that. So a very similar process to the last slide, except I've changed the length of each side, which means I've changed how wide the compass is open. When I draw the triangle in, this now gives a very accurate representation of this diagram. It's all to do with using your compass accurately, opening it to the accurate amount each time. Okay, so your first task, I would like you to pause the video at this point, and for each of these triangles, I would like you to produce an accurate diagram from the information you are given. So at the minute, all 3 questions are not drawn to scale. So your final answer may not look in the same proportions as these questions because they are not drawn to scale. However, you should be able to, by using a ruler and a compass, produce an accurate scale drawing for each of these triangles. Could you pause the video and have a go at that now? Okay, welcome back. Hopefully you were able to complete those 3 triangles accurately, and if your triangle measures correctly, then you know you've done things properly. So you would have used your compass to draw in the 9 centimeters and the 11 centimeters. If you want to double check your work, just take your ruler, measure all 3 sides, and if they are all accurate, then you know you've done the question correctly. Very well done. Okay, the next construction to look at is constructing the perpendicular bisector between 2 points. So if we put that into a little bit of context, if this ship was sailing and wanted to sail in between 2 rocks, it doesn't want to go too close to this rock and it doesn't want to go too close to this rock. So the safest route for the ship is to go along a line which is exactly halfway in between this rock and this rock. So the ship wants to keep as far away as possible from the 2 rocks. So what we're going to try and do, if we imagine a line going from this rock to this rock, we're going to find the perpendicular bisector of that line, the halfway point of that line. To do that, we would place our compass on this rock and draw a nice big arc, like that. Make sure you've opened your compass so it is over halfway. Then you take your compass and without altering the width, without changing how wide the compass is, you place it on this rock. And again, we're going to draw a nice big arc. Looks something like that. You'll notice there is a cross at the top of the arcs where they meet and a cross at the bottom of the arcs where they meet. The line that goes through these crosses is exactly the same distance at the center away from this rock and this rock. So the line through the middle is the safest route for the ship to travel on. So if the ship was to travel along the red line, it would be the same distance away from this rock and this rock at all times. Let's have a look at that a bit more mathematically. This construction is known as the perpendicular bisector. So if we have a line that connects 2 points and we want to find the halfway point of that line, we use this construction to find the perpendicular bisector. It always creates a right angle between the perpendicular bisector and the line connecting the 2 points. Okay, so let's have a little look. If I want to find the perpendicular bisector of this line, I would draw some equal arcs from A and B. So from A, I place my compass on A, I open it more than halfway, I draw a nice big arc and finish there. Then I take my compass, place the point of the compass on B. Again, make sure you have not adjusted the width of the compass. It should be the same width. And then we draw another arc going this way. Again, we have a point that crosses above the line and a point that crosses below the line. When we join those 2 lines, when we join those 2 intersecting points, it creates a nice straight line. There's a right angle here, and the red line is the perpendicular bisector of the line AB. It cuts the line AB exactly in half. Right angle displayed between the perpendicular bisector and the line AB. Any point on the bisector is equidistant from A and B. So if I take this point here, the distance from here to A is exactly the same as here to B. And that would be the same for any point on the red line. So any point on the line would always be equidistant from A and B. Okay, another construction we need to be aware of is finding the angle bisector. So can we cut an angle exactly in half? Okay, so to start with, we're going to put the point of our compass on A. We are going to open the compass out and we're going to draw a nice big arc here. Notice that it cuts this line AB and it cuts this line AC. Then you take your compass, you place the point of the compass here, you open your compass out and you draw an arc somewhere around here. Okay. Then you take your compass from this point and put the point over here. At this point, do not alter the width of the compass. It must remain consistent. Then we open the compass from this point here, and again, we draw an arc here, which will hopefully create a cross with this blue dotted line. There we go. If we look at the center of the cross and draw with a straight line through the center of the cross, all the way to the angle, that will create the angle bisector. So that red line has cut the angle exactly in half. We found the angle bisector. Any point on the bisector is equidistant from AB and AC. So any point at all along this line, wherever that dot was to stop, would always be equidistant from the line AB and the line AC. Okay, just going to do two more examples for you. So I'm going to construct the perpendicular bisector of this line, and then I'm going to construct the angle bisector of this angle. Question 1. First arc looks like that because I've placed my compass at this point. Then I move my compass over to this point and draw in my second arc. They should cross above the line and cross below the line. Then I use my straight edge or ruler to join the 2 points up, and that creates my angle, my perpendicular bisector. Okay, quick recap from me on these two constructions. If we're constructing the perpendicular bisector, we place our compass on one side of the line and we draw an arc. So my compass point starts here, nice big arc. Then I take my compass without altering the width and place it on the other side of the line. At this point, we draw another nice big arc. You'll see that it crosses above the line and crosses below the line. With a straight edge or ruler, we draw a nice straight line through each point, and the blue line now represents the perpendicular bisector. We should always end up with a right angle at this point, which we do. If I want to move on to question 2 and find the angle bisector, I start with my compass on this point and I draw an arc which crosses both lines, something like this. So the arc crosses this line here and the arc crosses this line here. Then I take my compass and I place it at this point. I draw a nice arc here. Then I keep my compass open the same width. I move my compass point over here and I draw another arc this way. Notice that the arcs cross, they cross at a point. Then I take my ruler or straight edge, draw a nice straight line through the cross up into the angle like that. So the blue line is showing you the angle bisector. We have cut that angle exactly in half. And these are two very common constructions that you may be asked to do in your exams. Okay, so here's a task for you to do. At this point, you have the ability to pause the video. What I would like you to do is in your exercise books or on paper, I would like you to draw out these lines. At the minute, they're not drawn to scale, so you need to draw out an 8 centimeter line, draw out a 6 centimeter line, and an 11 centimeter line. And for each of those lines, construct the perpendicular bisector. Then I would also like you to have a go at 3 angles. Again, they're not drawn to scale. I would like you to simply draw an acute angle, draw a right angle, and draw any obtuse angle. And find the angle bisector of each of the three angles. So my questions aren't drawn to scale, but you should be able to have a go at all 6 constructions if you pause the video now. Okay, welcome back. Hopefully you now have completed 6 accurate constructions. Let's have a look at a few more constructions that you can complete along with me. Remember, you have the ability to pause the video at any point if you want. Okay, if I want to find a 60-degree angle, I could start with my baseline. And remember, in an equilateral triangle, all angles are 60 degrees. So I could use that fact to help me construct a 60-degree angle. So I've drawn in, as if I was going to draw an equilateral triangle. Whatever the length of this base was, I've used that as the width of my compass, placed the point here, drawn a nice big arc. Then I've placed the point here, drawn a nice big arc. So when I join this to this, as if I was creating an equilateral triangle, what I've created at this point here is an accurate 60-degree angle. You can see my 60-degree angle there shown in red. So we're basically following the same construction as we did for an equilateral triangle. If we wanted to work out a 30-degree angle, 30 degrees being exactly half of 60, how do you think we would go ahead and do that? You could pause the video at this point and have a go at it yourself, or you could work through it with me. To start with, I'm going to draw the base. I'm going to approach the question as if I was constructing an equilateral triangle. So whatever the length of this base is, I'm going to open my compass that width, and I'm going to draw in an arc. Then I'm going to move it onto this side and draw in another arc. Then if I go ahead and draw in my equilateral triangle, you can see, or the start of my equilateral triangle, you can see that I have a 60-degree angle. Everything is exactly the same as this question so far, but we want a 30-degree angle. So what I'm going to do is I'm going to take this 60-degree angle and I'm going to construct the angle bisector. So if I split this angle exactly in half, the result will be a 30-degree angle. Okay, so I've then, once I had my 60-degree angle, I constructed the angle bisector of that 60-degree angle to be left with a 30-degree angle. Again, we start by using the equilateral triangle, but then adding on the angle bisector construction. Okay, 2 more for you to have a go at. Again, you have the ability to pause the video at any point if you want to have a go at these yourself, or if you want to work along with me. To produce a right angle, we are going to use the perpendicular bisector construction. I've mentioned a lot in this video. When you apply the perpendicular bisector construction, the result should always be a right angle. So when we add this perpendicular bisector, this angle created is always 90 degrees. So that is giving me a 90-degree angle. Okay, so let's also have a look at constructing a 45-degree angle. Again, you can pause the video if you wish to have a go at this yourself. 45 degrees is exactly half of a 90-degree right angle. So we are going to start by constructing the perpendicular bisector of a straight line, which will help us find our 90-degree angle. So we're now dealing with a 90-degree angle, and I'm going to use the construction, the angle bisector of this 90-degree angle to result in a 45-degree angle. So there's my 90-degree angle. I've started the construction of the angle bisector. I'm going to join it up with a straight line. So this is the angle bisector of the 90-degree angle, leaving me with a 45-degree angle. So we're still using the perpendicular bisector to get our 90-degree angle, but then we're halving that by applying the angle bisector construction. Okay, so now I'm going to talk you through two challenge questions. Again, you can pause the video at any point if you want to work through this yourself, or you can work along with me. I would like you to draw a triangle and construct a perpendicular bisector of all three sides. So your triangle can look like any triangle, and you should be finding the perpendicular bisector of each side. It should look something like this, but probably not exactly like mine, depending on what your original triangle looked like. You should see that at some point your three perpendicular bisectors all meet at the same point. It might be inside or outside the shape. This should happen no matter what the triangle looks like. So now what I would like you to do is I would like you to use the point of intersection, which is this point here, as the center of a circle, and I would like you to draw the smallest possible circle that does not go inside the triangle. So here's quite a large circle, but that is not the smallest one I can have, so I'm just going to reduce it slightly. So what you should find is when you draw a circle with your compass point at the point the three perpendicular bisectors intersect, the 3 points of the triangle, the 3 corners of the triangle, should fit inside the circle exactly, should touch the circle exactly. And that should happen no matter what your original triangle looked like. Okay, so this is the last challenge question from me. Again, you can pause the video if you want to have a go at this yourself, or you can work along with me. I would like you to draw a triangle, any triangle, and construct the angle bisector of all 3 corners. So I'd like you to draw a triangle and then apply the angle bisector construction to each corner. There's one, there's another, there's another. So what you should find again is that all 3 angle bisectors meet at a certain point. This time, because of the nature of angle bisectors, the point should be inside the triangle. Okay, so now using the point of intersection as the center, so I want this as the center of your circle, can you draw the largest possible circle that does not leave the triangle? So I've drawn in a circle here with the center at the point of intersection, but of course this is not the greatest circle I could place inside the triangle. So I'm just going to expand the circle, make it a little bit bigger. There we go. So what you should find is that the circle touches each side of the triangle. And this will happen no matter what your original triangle looked like. Okay, if you've been able to create some good constructions, some triangles, some perpendicular bisectors, some angle bisectors, then that's great. You've shown some very good understanding of the topic of constructions.